Yes. All right, I'm on. How are you guys doing? Excellent. Ooh, yeah. All right. So I'm going to show you how, I know there are a lot of acronyms and you've described a lot of the technology behind this. I just want to show you how easy it is to build sophisticated geo-distributed applications with CRDTs. And when I say easy, I mean really, really easy. What I mean is your marketing department can write this code. I love you guys. I just like to open up with offending some people. It's always a good open. Anyway, let me set the stage. The app that we're going to look at is a social app. We're going to do opinion polls. We're going to run many opinion polls on the site. You're going to see a lot of load. We've got users distributed around the world. So we've got some users in the US doing polling and voting for things that they actually like. We've got people in Europe voting for things. So you're going to see all of this load that's going on. Now I'm going to slice through this application. I'll show you the layers of it, but we'll take a look at the geo-distributed setup. Then I'd like to show you the Redis enterprise cluster that's running behind the scenes and running all the operations. I'll show you what the app looks like. We're going to show some real-time results directly to the end users who are voting. And I'll tell you what the developer had to do to write all of this code. So that's the way we'll actually go. All right, let's kick off some load. All right, so this is the West Coast users. What they're doing when they log into the site, the million operations, over 1 million operations that you see here, what they're doing is they're coming in, and we track two things about them. What are they looking at? We track the number of views that they've actually, the items have received. And then we'll track the things that they're voting for. So the million operations that you're seeing, well over 1 million, is also being performed in less than half a millisecond of latency here. So all you see right under the bubble is the local workload. As I said, we've geo-distributed the application, so let me kick off some additional load. Actually, let me show you what the cluster looks like right about now. All right, so this is actually a fairly small cluster. It's 3 nodes, 4 shards, and let me show you the stats that are going on. So the million operations over second, right here at the top, you see the ops per second and the latency. Right, this is going on, and this is a real deployment. So we've got the other geographies as well. Let me kick off some more load. So what I've just done is allowed the East Coast users to start voting on the opinion polls as well. Not only are these clusters doing their local work, they're also reconciling the results that they actually have from other clusters. All right, let's do one more, and that's Europe. So we're above 4 million operations per second at this point, and we can tackle this. And this is all built on CRDTs. All right, so let me click directly into one of the polls that's going on. So we're going to be seeing this real time. We're going to be voting for our favorite alien. So Yoda, my favorite planet Pandora. So Nature is there. And the guy with some anger management issues, Xenomorph, is there. So let me kick off the views over here is what we're actually looking at. So you'll see each one of these bars under Yoda is representing the geographies and the views that we're actually getting from them. Now, Yoda, the red bar is the West Coast, the blue bar is the East Coast, et cetera. The problem, which Rivta touched on, is we have views in Europe, we have views in the US, but if you got 100 views in Europe and 10 views in the US, you don't want the result to be 100 or 10, you want the result to be 110. So what we actually do in this case is we use a string, a counter, with an increment operation. And all the developer has to do is just basically, in each geography, every time somebody looks at Yoda, go to the Yoda views key and do an increment operation. What CRDTs allow us to do is to understand the developer's intent and correctly replicate the information across sites so that your counter doesn't get picked on one side or the other, but it gets accumulated over the tree. Now, votes, very similar. We use sets for this. We want to track the profile of each one of the voters. We want to see what they're voting for. We also want to prevent duplicates. So we use the sets, and all the developer has to do, again, is just do an add every time somebody votes for Yoda, for the key that is associated with that item. In a system where CRDTs don't exist, you obviously would have many people voting for Yoda in Europe, many people voting for Yoda in the US, but you would have to pick one of the two. So last right wins doesn't work, but CRDTs can actually simplify this a lot. All right, so I'm going to stop the load. What we expect to see is all 3 clusters to agree on a final result when I close this poll. And you can see that the lines flatten and the clusters converge very quickly on this poll. And most importantly, Yoda, the good guy, is the winner. Yes. Thank you, thank you. So the point I want to make is CRDTs simplify developing these sophisticated, complex, distributed applications much, much simpler. If you're developing fraud detection applications that are capturing distributed events, if you're doing distributed metering applications or scoreboards or dashboards that are capturing events in different geographies, if you have social timelines that you're constructing, a smart timeline that needs to converge, or a group chat application that needs to correctly display the conversations that are happening in real time, CRDTs is the best way to do that.